In this video, we're going to look at factoring special quadratics, specifically difference of squares and perfect square trinomials. So what I've done to start is just take a look at our three formulas and where they come from. So you don't have to write these down just yet. I just wanted to show you where they come from before we start using them. If I do a plus b times a minus b, so I'm multiplying conjugates, which means that they're the same except the sign in the middle, what happens is my outer and my inner, my two boxes there, subtract out. So I get a squared minus b squared, which is why it's difference of squares, subtraction with perfect squares. Then we have our perfect square trinomial, either a plus b squared or a minus b squared. So for a plus b squared, remember you're going to do a plus b times a plus b. And then what happens here, when I combine like terms, ab plus ab is 2ab. So I get a squared plus 2ab plus b squared. And if it's a minus b squared, when I combine like terms, I get a negative. So you probably do want to pause for a moment and let's write down our special cases that we have. Difference of squares, should really be an S on the end of that, and perfect square trinomial. So these are the patterns that I'm going to be using. The first thing we need to be able to do is recognize when we do in fact have perfect squares. So our perfect squares 1, 4, 9, 16, 25, 36, and so on. Looking for those perfect squares is important. We're going to look to see when they are perfect squares if it does in fact fit our pattern, and we're going to use square roots in order to find our values for A and B. So again, you want to check for those perfect squares, take square roots, and make sure that we fit the pattern. Pause if you need more time. I'm going to start looking at our examples. So starting with this first example, 4x squared minus 49. First of all, it's two terms, it's subtraction, and they are perfect squares, the 4 and the 49. So this one is difference of squares. So I'm going to find my a and my b by taking the square root. So square root of 4x squared is 2x, square root of 49 is 7. I'm ignoring the negative because it's part of my formula. And then I'm just going to do a plus b, a minus b. So I don't have to go through the long process of factoring. If I wanted to, I could put a 0x in the middle and do the whole process for factoring a trinomial. But if I recognize that it's difference, subtraction, with perfect squares, then that'll do it. And that saves me a lot of work. And again, I just followed my pattern, a plus b, a minus b. Okay, our perfect square trinomials are a little bit more complicated. So they're going to be with trinomials, and what you're going to look for is perfect square, perfect square. That's what you're going to look for. I could do the whole method. 4 times 25 is 100. Look for multiples of 100 that add to negative 25. But it's actually easier if I do A, B. But here's the key. I've got to check to make sure that 2AB gives me my middle term. Because if it doesn't, it's not a perfect square trinomial, and I can't use this method. So I find A by taking the square root, 2x. I find B by taking the square root of the last term, 5. And then 2 times A times B is in fact 20x. So it does fit the pattern. So this is going to be A. And because this is minus, this is going to be minus 5 squared. Again, I could go through the whole process, but I don't want to. I want to just use my pattern if at all possible. There we go. Okay, looking at the next one. Okay, I have, again, 9 and 64. I could do 9 times 64. Holy cow, that would give me a big number. So I'm looking at it and I think, ooh, but that's a perfect square, that's a perfect square. So I am going to try and see if I can use my perfect square trinomial. I find A by taking the square root. Well, let's try this again. I'm going to find A by taking the square root, 3x. I'm going to find B by taking the square root of the last term, A, 8. And then I need to check my 2AB. So 2 times 3x times 8. So 2 times 3 is 6, times 8 is 48x, so it does in fact work. Again, if I did not get 48x there, there's a problem. That means that it doesn't fit the pattern and I can't use this method. Since it does match, I can go ahead and do my 3x plus 8, so a plus b, because that's a plus, squared. And that's our perfect square trinomials. This part 6 is supposed to be down lower, so we're just going to ignore that, and that's the end of this video.